Welcome to another essential concept of Java, that is arrays. In this chapter, we are diving into how arrays let us manage and group multiple values together and use it as a single variable rather than having multiple individual variables. Whether it's a list of scores, names, integers, or even pixels in an image. Arrays are gonna help us handle this list of data or multiple values for a data in an organized and an efficient way. We'll explore what arrays are and why do they matter, different types of arrays, that is single dimensional array, multi-dimensional array, and as well as jagged arrays, how to declare, initialize and access array elements, the difference between static arrays and dynamic arrays, and we'll walk through a related practical code example to discuss how arrays work in code implementation. By the end of this chapter, you shall be able to use arrays in your Java programs confidently to store, process and manipulate the collection of data with ease. So let's get into it, shall we? An array in Java is like a row of labeled boxes. Each box can store one value and all the boxes must hold the value of the same type. Instead of creating separate variable for each value, arrays let us group similar elements, that is similar data, together under one variable name. Imagine needing to store the marks of 5 students. Rather than using student 1 marks, student 2 marks and so on, you can just create one array that would be the marks and that would hold the 5 values of the individual students' marks. Let's look at some of the key characteristics of array to understand them better. First one is the fixed size. Once you create an array with a certain number of elements, its size cannot change. In this example, int scores is equal to new int 10. So here 10 is the size of the array and it is always going to hold 10 integer values only. All the elements in array must be of same data type. That is, they could be integer, they could be strings or a custom object we create from the class. You can't mix multiple data types into a single array. In this case, the int numbers, they hold all the integer values. So this is valid. Whereas this 1, hello and 3, this is holding value of multiple types, that is integer and string. So this is not the valid array. The third one is the zero based indexing. The position of the first element of array is always going to start at 0. That is, 0 is the index value of the first element. The second element will be at 1. The third will be at second. So that is how 0, 1, 2, 3 the indexing works in array. Arrays offer direct access to a particular element if you mention where that index value is. That is, at which position in the array that element is present which you're searching for, and you need to specify that index value here. So based on the index position, array is going to give that particular value. This is efficient for quick lookups and data manipulation as well. Arrays work beautifully with loops like for, while, do while or for each. This means you can process and work on hundreds of elements present in an array without writing repetitive code. To sum it up, arrays form the foundation of many algorithms and data structures, as we'll see when we'll work on them later. Let's move on to declaring and initializing an array. In Java, you can think of declaring array as like saying, hey Java, I need a row of boxes to store the value of the same kind. How and when to choose to fill those boxes depends totally on your use case. Let's explore 3 most common ways to declare and initialize an array. The first one is just the declaration without the actual initialization. In this case, you are reserving the space for specific number of elements but not assigning the values yet. At this step, Java fills them with the default values. So here in this case, int numbers, new int 5. So here Java creates an array named numbers that can hold 5 integer values. But here we haven't assigned any 5 values to this arrays. So each element here is automatically set to 0 value. You can use this kind of initialization when you know how many items you're gonna store, but you don't have the values yet. This is perfect for scenarios where you are going to collect user input or generate values in the later step of your program. The second one is the declaration and the initialization in 2 different steps. In the first step, you're going to create an array. In the second step, you're going to assign values to that array. In this example, we first declare the array's number, but it is empty at this point. We initialize it with the size of 5, so it is going to hold 5 values, and then you assign values to individual elements using the index value. So here on the 0th index, that is the first element, you're going to store 10. In the first index, that is the second element, you're going to store 20. You can use this approach when the values are not ready at the time of declaration of the array, or in the later step when the values are gonna come out of some calculations, or you're gathering some user input, or you're querying data from a database. The third one is the declaration and the initialization in a single step. This is something you can use if you already know what values are gonna be part of that array. So in this step, we have created an array numbers and we have populated all the 5 values here in the curly braces. You don't have to specify the size. Based on the number of elements, Java is automatically going to get the size of that array. In this case, which is 5. You can use this approach when you have a list of predefined values, like let's say constants or some preset values or some random quick test data. With these 3 approaches, you now know how to set up and populate arrays in your Java code. Then comes the types of arrays in Java. Arrays in Java come in different size and shapes depending on what and how you're managing your data into an array. Let's explore 3 major types of arrays. The first one is the single dimensional array. This is the most basic type of array. You can consider values arranged in a straight line, like row of boxes or lockers or numbered containers. In this statement, what Java does is it's going to create 5 different boxes arranged in a single. You can store 5 different values, each value in a single box, and you can of course access each element using the index. That is, the first box is gonna be at the 0th index position. So if you wanna access the first element, you give it the index value of 0 and array is going to return that value to you. The single dimensional array is something you can use while storing names, marks, product prices, ages, anything you think can be managed in a single list. Then comes the multidimensional array. That is, it forms a structure of a table or a grid. That is when your data needs to be present in both the rows and the columns. That is how 2D arrays come into picture. Let's say we want to create a matrix of values. So we have created this 2-dimensional array here. We have specified 2 brackets here. So that is 2-dimensional array. So here the name of the array is matrix and we have given it 2 sizes, that is 3 and 4. That is, it is going to have 3 rows and 4 columns. You are going to store 12 values in this multi-dimensional array. That is 3 into 4. You get 12 positions, 12 boxes, and you can store 12 individual value, that is a single value inside each box. You can imagine this like a grid or a chess or a simple Excel spreadsheet. And in case of multidimensional array, you can access the element using the 2 indexes. You need to specify 2 indexes here to access the particular element. One would be from the row and one would be from the column. This is particularly useful while representing tables, images, scoreboards, or any data that could be arranged into matrix structure. The third one is the jagged arrays. This is like the arrays of arrays. The jagged array is a special type of 2D array where each row can have different number of columns. So it is not uniform. It is not a complete table structure. Each row can have separate number of column values. So in this case, int. So this is 2-dimensional array here, and in jagged array you get mu int. So here we have specified the row first, that would be the 3, and for each row, that is the 0, 1, 2. For each row we have specified separate number of columns. So here the first row is gonna have 2 columns, the second row is gonna have 4 columns, the third row is gonna have 3 columns. So each row can be considered as its own single dimensional array. So that is, each row can have different lengths. You can consider this like a seating arrangement in a movie hall. That is, some rows are gonna have more seats than others. To sum it up, no matter the shape, arrays are gonna help you store and manage multiple values together more efficiently. And based on your problem statement, you can pick any array from these 3. Let's move on to the types of arrays based on the declaration. Java gives us 2 ways to work with arrays, depending on whether we want the fixed size or a variable size. Let's explore the first type, that is the static arrays. These are going to be fixed and predictable. These are going to be the fixed arrays. That is, a static array has a size which once defined cannot be changed. That is, once declared, you cannot add or remove elements from it. So in this case, we have defined a static array. It looks much more like a single dimensional array where we have just initialized and assigned values as well. So in this case, this array has 4 fixed fixed positions. We can access these elements, we can change these elements, but we cannot add any additional element into this array. This has 4 elements, we cannot add 5th element into it. This is great for constant values like the days of week or the months of the year. And being static, these are very simple to declare and fast to access. These are also memory efficient since the size of array is fixed. Then comes the dynamic array, which is more flexible and expandable. This is a concept of array list, which we will see in the later sections, but let's quickly just go through what an array list is. So if you have a requirement where the number of elements in an array is going to grow or shrink, you can go with a construct called ArrayList. We have ArrayList as a class from the util package. We first need to import that, and then you can create an ArrayList. So this is going to be a dynamic array, so that's the name of the variable here, and integer. So this is a wrapper data type. So you specify the wrapper data type here for ArrayList. So this is going to create a list of integer and at this moment you haven't specified the size here because dynamic arrays don't need the size to be. You can just keep adding elements into this dynamic array. You do that by using the add method. So add 10. So this is going to add 10 into this integer array. Similarly, we can add 20. We also have a method to remove a particular element from the array. So here in this case 0. So this is going to take the index value of which element you want to remove. So in this case it is 0, that is the first element. So 10 is the first element which was added, so it is going to remove that 10th element from the array. An array is going to just contain 20. So that is how you can use the add and the remove method while using the array list concept. What's happening here is the array starts empty. We can use the add method to add any element at any time. Similarly, we can use the remove method to remove element at any time. We can use this when the numbers, that is the size of the array, is not constant, it's not specified, it's not fixed. This is useful to gather user inputs, dynamic lists, or collecting real-time data from, let's say, any sensors. And the benefit dynamic array brings is you don't need to declare the size upfront. This comes with the predefined methods like we saw, the add method, the remove method, as well as we have a contains method which helps us check if a particular element is present in that array or not. ArrayList is a part of Java collection framework which we will see in the later chapters. It's going to help us a lot when we are dealing with a bigger volume of data. Choosing the right type of array totally depends on your problem statement and your data. So I've created a class for it. This is our chapter 12, arrays in Java. I've added some comments and print statements here for each type of array we are going to work on. The first one is the single dimensional array. This is the most simplest kind of array you can define. So let me just create an array. So this is the name of the array here is numbers. We have declared and initialized and we have assigned values to it in a single step here. So this is a single dimensional array. Now if you want to print out a specific element from this array, you can simply use a system.out.println statement. And here you can access that value using the index element here. Element at index 2 is equal to, so here this is the 0th element, this is the first element, and this is the second element. So if I save the program and run, the expected value should be 30. You see the element at index 2 is 30. So it is working as expected. Let's say if you want to print out all the values present in this array, you can use a simple for loop for it. The way we define that is like this. So for int I is equal to 0, I is less than numbers dot length. Now dot length here is a method which is available for arrays. You can use this method to get the size of the array. So in this case, it is going to check as long as the I value is smaller than the length of the array, it is going to run that loop. And here we are incrementing it I++. And we are using a simple print statement to print the element at index. We are printing the index value here as well. So it is going to start with 0 if you remember. And here we are going to use that index value and print out the element present for that array. So let's save the program and run. You can see it is going to print out all the values. So it starts at 0, 1, 2, 3, 4. So it has total 5 elements. So since the index is starting at 0, it's coming off as 4. So that is how you can use a simple for loop to print out all the elements present in that array. Next comes the two-dimensional array. So this is going to be a matrix of values, and you can create a two-dimensional array with something like this. So here we are specifying two brackets indicating two sizes. Then we have the variable name, and here we have created three individual lists of elements. So this is going to be row 0, this is going to be row 1, and this is going to be row 2. And here 147, this is going to be column 0, 258 is going to be column 2, 369 is going to be column 3. So that is how two-dimensional arrays work. We can also print out individual element using the index value here with something like this. So element at row 1 and column 2. So we need to specify two values here because there are two indexes in two-dimensional arrays. So the first row and the second column. Here in this case, this is going to be the first row and this is going to be the second column. So that is 0, 1, 2, second column. So it should technically print out 6. So you see element at row 1 and column 2 is 6. So it is working. And let's say we want to use a for loop to print out all the elements of matrix. Now since there are two dimensions here, one is the row and another is the column, we are going to need two for loops. That is a for loop inside. So you can do something like this. We have created our first for loop. So int I is equal to 0, I is less than matrix dot length and I plus plus. So this is going to evaluate the overall length of the matrix here, which in this case is and then we have another for loop present inside the first for loop. That is, it is a nested for loop here, and it is going to use a separate counter variable. J is equal to 0 and j is less than matrix dot I length. So we are passing the first counter value here in the row. We are evaluating column for the second for loop. So we need to have rows. So in this case, matrix 0 is going to give the first row, matrix 1 is going to give the second row, matrix 2 is going to give the third row. And then we are incrementing it, and we simply now write here a simple print statement to print out that variable I and j. So these are like the index dimensions. In this case, this loop is going to run 12 times. So if we save the program and run, now you see it's printing that element as expected, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is how you work with multi-dimensional arrays. Then comes the three-dimensional array. In the similar way we have created two-dimensional array, we can create a three-dimensional array. The first dimension is 2, the second is 3, and the third is 4. Let's quickly assign a value. Now three-dimensional arrays are a little difficult to visualize, so hence we are straight away going to assign a value on one of the index position here. So we do that by using the array name, and this is the index position. So this is going to be the first row, the second column, and in the third dimension it is going to be the third array. So we have set that value to 100. So if we save the program and run, you see it is giving out that value. So you can of course use the for loops to populate the elements in a three-dimensional array. So, and you can definitely play around it. Now moving on to the dynamic array, this is an interesting concept. You declare an array list using an ArrayList class. So here you see that we have created ArrayList of integer wrapper data type, the name of the array, and here we are not specifying any size if you observe, but you also see we are getting this error because we have not imported the util package yet. So it gives us this suggestion to do that, and once it's done, you see it has imported that util class, and that error has gone here. Now you can start adding elements to this array dynamically. We are adding 10 into this array, we are adding 20 into this array, we are adding 30 into this array list. So that is how you can keep adding elements into this dynamic array. We can also remove a particular element using the remove method with something like this. So here in this case, remove 1. So this is going to remove the first index element. So that is going to be the 20th element. So this is the 0 index, this is the first index. So it is going to remove 20 from the array list. You don't really need a for loop to print out all the elements present in an array. You can simply write the variable name and it should print out all of the values present as part of that array. We have removed 20, so hence we are getting 10 and 30 here. And similarly, you can also use a for each loop. We have looked at this concept in the looping section. You can use a simple for each loop as well. So int element, so this is like a temporary counter element, and this is the actual dynamic array list. For each index position, it is going to print out that element value here. So it should again print out like 10, 30. So this is how it is working. So you can print out the elements of array using a simple print statement, or you can use a for loop or for each as well. And that is about the code example related to arrays in Java. Let's quickly go through some of the best practices and tips while working with arrays in Java. Pick the right type and the size. That is, choose the correct data type for your array and decide the size of array very wisely, because once the size is set, you cannot change it until and unless you're using an array list for it. Initialize your arrays with meaningful values. Even though Java is gonna provide default values to an uninitialized array, it's always a good practice to initialize your array with some values whenever you can. You can go with the enhanced for loop, that is the for each loop, while working with arrays or array list. This can help avoid common indexing problems which you might encounter while working with arrays. Fourth one is the avoid indexing errors. That is, the index of an array starts at 0. So you need to remember, always check for the higher bounds, that is the total number of elements that are allowed in an array, to avoid array bounds exception. Try not hard coding the length of an array. Always try using the .length method. This is going to help your code stay safe and dynamic. Use arrays utility class. That is, Java's arrays class offers easy sorting, filling, and printing, so you can leverage those methods to work better with arrays. Use ArrayList for flexible size. That is, when the size of your collection is gonna change, it's better to use ArrayList. Always check that your array doesn't hold any null values. You can avoid the null pointer exceptions while working with arrays by just checking if there is any null object present in that array. That is, validating the elements before using them. And that wraps up this chapter about the arrays in Java. In this chapter, we learned how to declare and initialize arrays in different ways, the difference between a static array and a dynamic array, and when to use each, the concept of single dimensional array, multi-dimensional array, 3D array, and jagged array, some of the best practices and tips while working with them. With this knowledge about arrays, you are now better equipped to structure and manipulate data in Java programs with confidence and clarity. This chapter also marks the ending of the second section, that is Java Basics. We have built a good foundation to work on in variables, data types, expressions, operators, control flows, loops, and finally arrays. Coming up in the next section, which is gonna be all about object-oriented programming in Java, we'll understand how to model real-world problem statements into classes and objects, understand the concept of encapsulation, inheritance, polymorphism, and abstraction. This is where we go from writing basic Java code to designing flexible and modular applications. And that's about this chapter. I'm Venkatesh Mudaliar. We'll see you again in the next one. Cheers.